Hey everyone! So this is just kind of like a what would this stream output type of video. So I'm just going to be going over examples of streams and then what you can expect the output of that stream to be. So for the first one, just starting it off easy, so I want to define the stream ones. And what this looks like is a const stream of 1 and 1s. So this is probably the first tricks of defining streams, which is defining them in terms of themselves, right? So I'm defining the variable 1s. Variable 1s is set equal to this stream, where the first thing is 1, and the second thing does not get evaluated. So when I first put this in, I type in 1s, we see this hash promise. That means that again, const stream does not evaluate its second argument, so it evaluates the first thing, that's why we get a 1, and then we get this hash promise because we haven't evaluated the second thing yet. The hash promise is not forced because we have not seen what's underneath that promise yet. We have not forced the evaluation of that promise. But we can do that by calling stream_cdr on 1s. So if I call stream_cdr on 1s, I'm forcing that evaluation, and so now I get 1.promise, 1.hash promise, and this promise is forced. So how come this promise is forced? It's because we looked at the cdr of 1s. The cdr of 1s is itself. So it points back to the beginning of this stream, and since we just stream_cdr'd this whole stream, this promise has been forced. Okay? So again, the rules of identity are the same. Since 1s points to this same stream, and we just looked at the cdr of this stream, the promise has been forced. Okay, so there's that. Let's define 2s, and we'll just do a const stream of 2s. So we're going to do the same idea here. So if I type out 2s, it's going to be a list of 2s. So let's interleave 1s and 2s. Okay? And so what interleave does is first what SS does is it outputs the first 10 items of whatever stream it's given. And it forces all of those promises. So that means that if I ever typed in 1 again, the first 10 promises would all be forced. Same for 2s. So what interleave does is it returns a stream of the elements of 1s alternated between the elements of 2s. So then we would expect this to be 1, 2, 1, 2, 1, 2, 1, 2, because the stream, where the elements of this stream are interleaved between the elements of this stream. Okay? So there's that. So then now, let's do, just a sec, sneaking over to my Sublime over here. Okay, so now I'm going to define this hasEven predicate. So what this hasEven does is it takes in a stream, and it has 2 stopping points. It either returns false if the stream is empty, or it returns true as soon as it sees a even element. Okay? Otherwise, it keeps recursing until it finds either an end or an even element. Okay? So there's that. So I'm gonna, just really quick, I'm gonna just clear this so we can bring that up there. Okay. Okay. So just gonna put hasEven back in there. So then what happens if I do hasEven of 2s? So again, hasEven has 2 stopping points, either if it hits an even number or if it hits an end. So it'll probably hit an even number, right? Because 2s is just a stream of 2s. Okay, so then what if I put 1s back in here? What if I do hasEven of 1s? So does 1s have any even numbers in it? No, so it's not going to hit that stopping point. But does 1s have an end? No, right? 1s keeps looking at itself repeatedly. So was this going to stop? No, it's not. It's not going to stop. So that would be an example of an infinite stream. or that would be an infinite loop because we'd be going over an infinite stream looking for an end. Okay, just going to clear this again. Sorry about that. Okay, so I'm just going to put ones back in there. Okay, so let's move on and define just a normal function, no streams here. Let's define foo to be x plus 1. Okay, so foo takes in an x, just adds 1 to it. Okay, so let's define now the stream bar as follows. So this bar is some variable that outputs a stream. The first of the stream is calling foo on 1, and the rest is just some stream we don't care about yet, right? Because const stream does not evaluate its second argument. So then we know that it evaluates its first argument, so foo of 1 is 2, right? So if I typed bar into here, I should expect to see what? 2 hash promise, right? Because this is 2. Okay? So then if I do the stream car bar, I should get 2, right? So again, const stream evaluates its first argument. It will never evaluate its first argument again. This is already evaluated. It never recalculates this. So this will be forever, will be 2. Okay? So then what if I want to redefine foo? So let's say I want to define foo of x, but I want to now define plus x of 5. Okay? So now foo, instead of adding 1, now adds 5. Okay? So then, what happens? Take a moment and think, what happens if I do stream car bar? So if I do stream car bar, again, it's never recalculated again. So this should still be what? 2. But what if I do stream cutter of bar? If I do stream cutter of bar, then we finally get to look at our rest, right? This is the first time we're looking at the rest of the stream. And so, since this is the first time we're looking at the rest of the stream, this is the first time we see foo of 2. So then, what is foo right now? Foo is no longer x plus 1. So what does foo of 2 get evaluated as? Since foo is redefined as plus x and 5, and this is the first time we evaluate this rest, we use this foo instead of this foo when we're evaluating the stream cutter of bar. Because again, this is the first time we get to look under this promise. So this is the first time we get to evaluate this and get to evaluate foo too. Okay, so what happens if I redefine foo again? So let's say I define foo, and now it's, plus x and 7. So then what happens now if I do stream cutter of bar? So again, once we calculate something in the stream, we never recalculate it. That's part of why streams are so efficient, because they never recalculate things they've already calculated. So since we've already calculated this, it'll still be 7. It won't be 9. Okay, so once again, just gonna clear things up. Okay, so once again, I'm gonna paste that ones in there. So let's say I want to define BOZ now. And so BOZ is a stream map of, oops, just a second. I'm gonna put foo back in here as well. That last one was x plus 7. Okay, so now I want to define BOZ, and I'm going to define BOZ as follows. So what is BOZ? BOZ is a variable that is bound to stream map of foo and ones. Stream map takes in a function and as many streams as inputs that function takes. So since foo takes in one argument, it will only have one stream that we put into stream map. So stream map takes in a function and a certain number of streams and it outputs a stream of that function mapped over that stream. So since we're mapping +7 over ones, we can expect BAS to look like what? Just a bunch of 8s. Because 1s is just a bunch of 1s, so mapping +7 to all of them should look like a bunch of 8s. Okay, so now let's define start naturals. And it's defined as follows. So I'm going to take in an x, and I'm going to constream an x with start naturals of x plus 1. Okay? Got prints. Okay, so if that's how I'm defining start naturals, this is kind of like how ones is defined, where it's defined in terms of itself, except for start naturals is a function now and not just a variable. And so does this start naturals point to the same thing as this? No, it doesn't. So if I force this promise over here, it will go to a whole new stream, not the same one. Okay? So if I do SS of start naturals of 0, what should I expect to see? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. First 10 numbers, right? Which makes sense. Because we constreamed 0, and then we did start naturals of 0 plus 1. And what's start naturals of 1? That's just another stream that starts with 1, and so on and so on. Okay, so what else can we do with streams? Well, let's see the first 10 elements of a stream filter. So what does stream filter takes in? Stream filter takes in some sort of function that filters a stream. Okay? So let's say that I want to take in some lambda that takes in an x and says whether that x is divisible by 2. Okay? And then let's filter that with start naturals of 0. Okay? So what are we doing here? So stream filter returns a stream where it's going to be this stream, but with only the arguments such that this is true. So stream filter only keeps the arguments, it only keeps the elements of this stream for which this function returns #t, or true. So since stream filter returns a stream of all of the elements of start naturals that are even, we can expect this to output something like 0, 2, 4, 6, 8, so on and so on. Okay, so just a few more. So what about interleave start naturals of 0 and start naturals of 10? Well, that's going to be interleaving these elements with these elements. So what's the first element of this? 0. It's the first element of this, 10. What's the next element of this? 1. What's the next element of this? 11. So we can expect this to look like 0, 10, 1, 11, 2, 12, so on and so on and so on. Okay, so what if I want to do something like this? Let's say I want to define integers as constream of 1 and stream map of plus ones and integers. So this is getting a bit complex. So I'm defining this variable integers, where the first element is 1, and the next element is a stream that's adding together the elements of 1s and integers. Okay, so what is this going to look like? Well, by its name, we can expect this to look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's kind of like cheating. You won't have that on a test as much. So then let's look in here, okay? And we'll get to that next one. Boop. Okay. So define integers, which is const stream of 1 and stream map of 1's integers. So we have what we know of integers so far, which is we have the first element. And then we know the next element is this stream of stream map, right? And so stream map is adding together the elements of 1s and integers. So the first element of integers will be 1. What's the next element of integers? Well, it's the stream map of adding the first element of 1s with the first element of integers. Suppose the first element of 1s, 1. What's the first element of integers? Well, we know it's 1. So then we put in 1 right there. And so the first element of this stream will be these added together. So that'll be 2, which will also be the next element of integers. Because again, the first element right here, the next element is the first element of this stream. So what's the first element of this stream? These 2 added together. So it'll be 2. What about the next element? Well, the next element of 1s is 1. Next element of integers is what? We just said it was 2. So what's 1 plus 2? 3. And then what about the next element? 1s. What's the next element of integers? We just said it was 3. So what's 1 plus 3? 4. That's kind of how you trace through these problems. Is you have this first element, and that's all you know, but you can use it to calculate the next ones. And once you calculate the first right here, that'll correspond to the second right here, and you can keep on calculating based on that. Okay? And we'll do one more of these. So what about here? So define S. S is the const stream of 1 and adding streams of S and integers. So again, add streams will return, it's not defined, but you can assume it'll return these 2 streams added together. Okay? So then if the first element is 1, what are the next 3 elements of S? Well, let's add it out. So we know the first element of S is 1. So add streams will add together S and integers. What's the first element of S? 1. What's the first element of integers? Well, up here we said it was 1. So add streams will add these 2 together. So what's the next element of S? 2, right? Because the elements of S are 1 and then whatever the stream outputs. So the first thing the stream outputs is 2. We just found that out. So that means the next element of S is also 2. What about the next element of S? Well, we know the second element of S is 2 now. What about the second element of integers? We found out was 2. So then what's the third element of S? 4. And then again, what's the third element of S? It's 4. What's the third element of integers? 3. So then what's the next element of, so it's the fourth element of S is 4 plus 3, 7. Okay, so that's kind of the trick of just tracing through these, just taking it one step at a time. Kind of drawing out these tables really helps kind of like keep track of everything.